The gasoline in your car and the red dye in your child's fruit punch start life as the same raw material. That is not an opinion. That is organic chemistry. And in the next 9 minutes, I am going to walk you through exactly how that works, so that by the time you finish watching, you will be able to read any food label and know with real precision what you are actually looking at. You are going to leave here with the chemistry, the regulatory history, and a framework you can use tomorrow at the grocery store. But before we get into the molecule itself, I need you to understand something about the phrase FDA-certified, because most people hear that and assume it means tested and proven safe. What it actually means legally is something quite different. That distinction is the single most important thing I will tell you today. I will get there in about 2 minutes. First, let us follow your Red 40 from the refinery. Red 40, full name, Allura. Red, ACFD&C, red number 40, is an azo dye. Azo dyes are built around a nitrogen-to-nitrogen double bond your body cannot process the way it handles natural colorants. The synthesis begins not in a food facility, but in petrochemical processing, specifically with aromatic amines derived from naphthalene, a compound extracted from coal tar and crude oil refining. You may know that name. It is the active compound in old-fashioned mothballs. It is a direct byproduct of the same refining process that produces diesel fuel. That is your starting material. From naphthalene, chemists produce a sulfonated aromatic amine, which then goes through a process called diazotization. In diazotization, your amine is treated with sodium nitrite and hydrochloric acid at near-freezing temperatures to produce a highly reactive intermediate called a diazonium salt. That salt is then chemically coupled with a second aromatic compound to form the azo bond. The result, after filtration, salting, and drying, is a red crystalline powder that gets shipped to a food manufacturer, dissolved into your sports drink, and passes through your gastrointestinal tract. Your label calls it Red 40. Now here's the part I want you to screenshot and share because this is what most people never hear. The phrase FD&C certified does not mean the FDA independently tested this compound for long-term safety. It means the FDA tests each batch to confirm it contains the correct molecule at the correct concentration. Certified answers the question, is this the right molecule? It does not answer the question, is this molecule safe for long-term consumption? Those are two entirely different inquiries. Your label only gives you the answer to the first one. Drop a comment right now and tell me honestly, did you already know that distinction existed? Red 40 was first approved in 1971. The original safety data supporting that approval was submitted by the manufacturer, not independently generated by the FDA. Since then, it has been reviewed several times, but it has never gone through the kind of long-term randomized controlled trial that a pharmaceutical drug requires before your doctor can prescribe it. Prescription medications go through 10 years of clinical trials before they reach your cabinet. The dye in your Gatorade was approved on industry-submitted data over 50 years ago. In my experience, about 1 in 20 people knows that. Now you do. You might reasonably ask, has not 50 years of widespread consumption served as a safety signal? That is a fair question, and I want to give you a real answer. The most revealing data point is not any single study. It is the regulatory divergence between the US and the EU. Both authorities reviewed the same research and reached different policy conclusions, and that gap tells you more about how food safety actually works than any individual experiment. Here's what I mean. In the European Union, products containing Red 40 must carry a label warning that the product may have an adverse effect on activity and attention in children. That warning followed a 2007 peer-reviewed study in the Lancet, the Southampton study, which found a statistically significant association between a mixture of synthetic food dyes and increased hyperactivity in children. The Food and Drug Administration reviewed that same study and concluded the evidence was not sufficient to require a warning in the United States. Same research, different outcome. If you are wondering how two major authorities can read identical evidence and reach opposite conclusions, stay with me. The answer is regulatory philosophy. In the European Union, the precautionary principle applies, and credible concern shifts the burden to industry to prove safety. In the United States, the burden falls on regulators to prove harm before restrictions are imposed. Neither system is irrational. They are different frameworks for scientific uncertainty. But understanding which system you live in explains exactly why your label looks different from the one on the same product sold in England. Here is your second question for the comments today. I genuinely want to know your answer. Your label is required to tell you that Red 40 is present. It is not required to tell you where the compound came from, how it was manufactured, or what your gut bacteria produce when they metabolize it. When your gut processes an azo dye, it can cleave a nitrogen to nitrogen bond and produce aromatic amine byproducts. None of that appears on your label. Do you think it should? Now let us talk about what is replacing Red 40, because brands are moving fast, and the answer is more complicated than the marketing suggests. Carmine comes from crushed cochineal insects. Annatto comes from the achiote tree. Beet juice concentrate gives a reddish hue. All three are being positioned as clean alternatives. But natural describes origin, not safety. Carmine can trigger anaphylactic reactions in people with certain allergies. Annatto has been associated with hypersensitivity in some individuals. You are not trading questions for zero questions. You are trading one set of questions for another. So here is the most useful thing I can leave you with. Certified and safe are not synonyms. You now know the difference. Regulatory approval is a snapshot, not a permanent verdict. And if you want to reduce your exposure to synthetic petroleum-derived dyes specifically, look for no artificial colors combined with no FD&C designations in the ingredient list. Both conditions need to be true at the same time, because a product can say no artificial colors and still contain color additives, just natural ones. Before I close, go to your kitchen or think about what you bought this week and drop the name of any product you own that contains Red 40 in the comments below. I'm not judging your choices. I eat things with food additives too, but I want to build a real running list because the pattern that emerges from your comments helps every person watching this understand what the actual daily exposure landscape looks like. I read every single one. The story of Red 40 is not ultimately about one molecule. It is about a system in which regulatory philosophy, manufacturing economics, and industrial chemistry interact in ways your label was never designed to communicate. Understanding this system does not require you to be alarmed. It requires you to be informed. There is a meaningful difference between those two things, and this channel exists to serve the second one. If this video gave you something you did not have before, subscribe right now because the next video covers the 31 dyes still approved while 6 get phased out. Hit the bell. Share this with someone who buys food, which is all of us. I'll see you in the next one.